Okay, so in this particular problem, we're going to solve this system of two equations and two unknowns, x and y. So we're going to solve this system of two equations using substitution. Okay, so to use substitution, the idea is we want to solve one of these equations for either x or y. It doesn't matter, just pick one. It looks like this is the easiest one, and I'll probably just solve that for y. All right, so that looks like the easiest, but you could solve this equation for x and then use that as your substitution. It doesn't matter, but I like just pick the easiest one to solve for. Here it looks like in this equation, let me call this equation 1 and this equation 2. So we solve equation 1. I'm going to solve equation 1 for y. So let me first just rewrite this. 2x minus y equals negative 8. So to solve for y, if I add y to both sides, I could have subtracted 2x. That would work as well. But I'm going to add y. So we get 2x equals negative y plus y is 0. And we get y minus 8, which is the same as minus 8 plus y. Now to get y by itself, I add 8 to both sides. And those add up to 0, and we get y is equal to 2x plus 8. That's the same as 2x plus 8 equals y. I just switched them. No big deal. All right. So because I solved equation 1 for y, I now want to substitute this result into this other equation. So this is saying in this equation, wherever there's a y, I want to plug in 2x plus 8. So I get 3x plus 4y, but for y, I'm substituting 2x plus 8. And this is equal to 10. So that's why it's called substitution, because we're substituting what we solve for in one equation, we're substituting it into the other equation. Now, this is just an equation that has x in it, and I can solve for x. So let's do that. Let me distribute the 4. We get 8x plus 32 equals 10. Let me combine like terms. 3 plus 8 is 11. So we get 11x plus 32 equals 10. Then we want to subtract 32 from both sides. That adds up to 0. And we get 11x equals negative 32 plus 10 is negative 22. Let me just rewrite this over here. So we have 11x equals negative 22. Solving for that, we got to divide both sides by 11. 11 over 11 is 1, and 1 times x is x. Negative 22 divided by 11 is negative 2. So we now know what x is equal to. X is negative 2, but we also want to know what the other variable, we want to know what y is. So now I can plug this x value into either equation. It doesn't matter which one you pick, because what we're finding here is when we solve this, we're finding the point where the two graphs intersect. The point where the two graphs intersect each other, that point, both graphs have the same x value and the same y value. If this is the xy plane, and these are our graphs, this is the x value, and this is the y value. If I pick this x value, well, they have different y values, yeah? This is the only one place where they have the same. So it doesn't matter which equation you plug this into. We could plug it in here, yeah, because we got y right there, but just in case we made a mistake or something, let's just plug it into either one of these. Let me plug it into this one. So we plug in negative 2, we get 2 times negative 2 minus y equals negative 8. And this gives us minus 4 minus y. Let me add 4 to both sides. And we get minus y equals minus 4. Multiply or divide both sides by negative 1. And we get y is equal to negative 4 over negative 1 is positive 4. So the solution to this system of equations is x equals negative 2, y equals 4, or it's the point negative 2, 4. That is the point where if I graphed these two equations, they would intersect each other at the point negative 2, 4. Now let me just illustrate here. Let's say instead of plugging it into this equation, I plug negative 2 in this equation. Let me just illustrate that it doesn't matter. So if I plug negative 2 in here, 3 times negative 2 is negative 6, plus 4y is 10. When I add 6 to both sides, we get 4y equals 16. And when I divide by 4, we get y equals 4. It's the same answer we got here. So it doesn't matter which one you plug it into. But that's the idea of solving a system of equations using substitution.